Hello, I'm John Ferris, and this is my video reflection journal number 5 to demonstrate and interpret one-way ANOVA using my K-12 student performance dataset. The purpose of this analysis is to determine whether there are statistically significant differences in math scores across socioeconomic status groups. And the first part of our analysis is going to be going through our question deconstruction verb analysis framework. Our research question is there a statistically significant difference in math scores among students among different grade levels in the K-12 dataset? The verb we identified is difference among, and this indicates a comparative analysis. We have both an independent variable and a dependent variable. Our independent variable is grade level, 3rd to 8th grade student groups. We will measure this level as a nominal measurement. We then have our dependent variable, which is the math score, student math performance scores. And we will measure these as a ratio score. In terms of test selection rationale, the research question uses a comparative verb, difference among, and the independent variable includes more than 2 independent groups, namely 6 grade levels. Therefore, a one-way ANOVA is an appropriate statistical test. The dependent variable, or math score, is continuous, or a ratio level, which satisfies ANOVA requirements. We will then identify our null hypothesis and research hypothesis. Our null hypothesis states that there is no statistically significant difference in mean math scores across grade levels. And this can be symbolized as indicated here as H sub O is equivalent or equal to mu sub 3, which is equal to mu sub 4, which is equal to mu sub 5, which is equal to mu sub 6, which is equal to mu sub 7, which is equal to mu sub 8, indicating no statistical difference between those mean scores. Our research hypothesis would be the opposite, indicating that there is a statistically significant difference in mean math scores among those grade levels. We will measure our alpha level as indicated here at 0.05. This alpha level is appropriate because it is the standard threshold used in educational research. It balances the risk of committing a type 1 error while still allowing sufficient sensitivity to detect meaningful group differences. From this point, we will go to our assumptions check, and these are indicated below. And of course, before we run ANOVA, we verify or need to verify all required assumptions in SPSS. First, independence of observations is met because each student represents a separate data point, as shown here. Each student is independent. Second, normality was assessed using SPSS tests such as Shapiro-Wilk and visual inspections of histograms and QQ plots. The distributions were approximately normal, as shown here. Third, homogeneity of variances was tested using Levine's test. The results indicated that the assumption of equal variances was met as well. Since all assumptions were satisfied, I proceeded to the one-way ANOVA. Now, let's walk through the path step by step. And we're going to run the analysis as indicated here. We will first go to Analyze, Compare Means, and then go to one-way ANOVA. Okay, at this point, I'm going to stop sharing my screen and go to the actual SPS screen itself to demonstrate how I went about doing that. Okay, let's go ahead and share screen. Let's see if we can get to our PS output file. We'll click share. And it should take us directly to our screen. Okay, at this point, what we'll do is we'll go, as indicated, to run the one-way ANOVA, we need to go to Analyze. We need to go from here to Compare Means. And from this pull-down menu, we go to one-way ANOVA. We click it. This portal should appear. We will then adjust this to make our computations. We will move the math score to the dependent list, as I'm doing here. And we'll move the grade level to the independent factor box, to the factor box. Okay, let's go ahead and move that there. For options, we will click on options, and we need to make adjustments here. Specifically, we need to select descriptive statistics and need to select homogeneity of variance test. We'll click continue, but we also have to take into consideration the post hoc. We'll click on the post hoc, and we need to make a couple adjustments here. Namely, we have to make sure that we indicate select Tukey and Bonaferroni. Okay. Then we're going to get out of this portal and click continue, and then click OK to run the analysis. When we run the analysis, I will stop share and then go to our results page. Since we've already run the analysis previously, we'll go to our output. I'm going to share screen once again to our output page. Now let's just give it a minute. Okay. In the output, at this point, this is our decision section. We need to make a decision. We'll report on the F statistic shown here, the degrees of freedom, and the p-value. As we can see, we have a decision here. To make the decision, of course, I compared the p-value to the alpha value of 0.05. Since p of 0.001, the eta squared, I reject the null hypothesis, as shown here. This means that there is sufficient statistical evidence to conclude that at least one SES group differs significantly in math scores. I also calculated the effect size using eta squared. And that's shown in these statistics here. Which we already was at 0.001 0.001. Most importantly, from our ANOVA table, we can read our key statistics from the output. Our F was 5. And 3617. We made the, excuse me, the F, of course, is the 0.495. The P is measured at 0.781, and the N is 3622. I want to make that clear because that's analysis. I want that to be correct. We also want to look at our group sizes and multiple comparisons. And that'd be the descriptives up here. And all of the means, as was indicated when we did the null hypothesis, all fell within that same level of 86. So this would correlate with the effect size, of course, being 0.001, and that's where it is right here, eta squared, very small effect. Okay, so thus our interpretation, which we know is going to be correct, is practically negligible difference between these groups. Okay, our post hoc results also show the same. That's those right here, posts as indicated here. They were all non-significant. P was less than 0.05. No grade levels differ significantly from each other. So thus, what is our statistical decision at this point? We failed to reject the null hypothesis. That's what this means, and I'll refer back to this 0.781 there at the top. There's the number there, and obviously the P 0.70 is obviously much greater than 0.05, and thus there is no statistically significant difference in math scores across grade levels. This means that students in grades 3 through 8 perform at very similar levels in math within this data set. Additionally, because of this 0.001 that we've got for the effect size, this indicates the grade level explains virtually none of the variation in math scores. Okay? From a practical standpoint, this suggests that grade level alone is not a meaningful factor influencing math performance. And other variables such as instruction, intervention, or socioeconomic factors may be more important drivers of student achievement. Okay, I'll stop sharing at this point. Then we're back to our sheet summary template. And thus read our APA. It is a one-way ANOVA was conducted to compare math scores across 6th grade levels. There was no statistically significant difference in math scores among the groups. F was 5, 36, 17, was 0.495. The P was, as we already reported, 0.781, and the effect size was 0.001. And all these results indicate that grade level does not significantly impact math performance in this data set. In terms of reflection, one challenge I did encounter during this analysis was interpreting of the normality results. The Shapiro-Wilk tests were significantly different, and statistically significant, which initially suggests a violation of this normality assumption. In future analysis, reminders for the future, I will remember not to rely on statistical tests for normality, especially when working with large data sets. Instead, I will use visual methods and apply statistical reasoning to make more informed decisions about assumptions. I'll go ahead and stop sharing at this point. This concludes my video reflection journal number 5. I thank you for your attention. If you have any questions concerning this analysis, please let me know. Again, thank you for your attention.